Hi there, my fellow learners. Setsu is back. If you are new to this channel, please don't forget to subscribe. I'm going to continue then now with this problem. Now we have a two-dimensional problem of electrostatic force, Coulomb's law, which states determine the resultant electrostatic force on QB. I still repeat again. For us to answer this problem, we must start by drawing what? The free body diagram. How are we going to draw the free body diagram? It is so simple. We are going to do like this. We're going to take QB and QC. You can clearly see that B is negative, C is positive. They are going to attract. Somehow B is going to act on that direction. Then let us do the same for B and A. Same, they are going to attract, but this time around B, it will go downward like this. You see? Then now, immediately after doing this, we then going to convert almost everything that we have. Charges into coulombs, our distance into meters. Then okay, let us convert. Firstly, we are going to start with our charges, which is QA plus 5 times 10. This time around we have microcoulomb. Microcoulomb is minus 6 coulomb. Then we take B, which is negative 10 times 10 to the power of minus 6 coulomb. Then our C is going to be 7 times 10 to the power of minus 6 coulomb. And now we have managed to convert our charges. Let us convert our distances now. Between R, A and B. This time around we have millimeters. Then we are going to divide this 10 millimeters by 100. Sorry, 1000 this time around, 1000. Then which is then going to be 10 divided by 1000. We are going to get 0,01 meters. Let us do the same for B and C. Divide 15 by 1000. Going to get 0, let me double check. We're going to get 0,015 meters. Then yeah. Then at this point, we have managed to convert everything. Then now listen. For the two-dimensional figure like this one, for us to determine the net electrostatic force, or firstly let me just focus on calculating the electrostatic force, then I will come to the net or the resultant. Then now I'm going to consider F of A and B. A and B, let us use our Coulomb's law formula. A and B, and divide by square R. We know that our K is a constant value, which is 9 times 10. 9. Our Q, A It's 5 times 10 to the power of minus 6. Then another Q E, which is 10. We omit the negative signs at this point. Then divided by R, which is between AB 0,01. Then we square everything. Then now let us use our calculator to determine the force between AB. Then you are going to get 4500 Newton. In which direction? Down. They eventually attract. But for B it will go down. Then now we have managed to determine the electrostatic force between A and B. Let us do the same for B and C. Going to say F, but this time around for B and C, equal sign Q, B, Q and C. Then we divide it by R squared. Then our K, the constant value. Then let us see what is the value of B. It was negative 10, but we omit a negative. We're going to consider only a positive. Then for C, 7 times 10 to the power of minus 6 Coulomb. Then right. Then the distance, it was 0,015. Then you square everything. Then at this point, we'll then use our calculator. When we use our calculator for this one, we are going to get 2800 Newton. In which direction? You can clearly see from our diagram that it will move towards the right. Then now we have managed to determine the electrostatic force of these two lines. For us to determine the net or the resultant of electrostatic force between these two, we are going to use a different method. We can clearly see that these two lines, they are perpendicular there. Then at this point, we are going to construct a line like this, which is going to be what our resultant force FR, this one FR. Then this one is going to be our F net, which is FR in this case. For us to determine this, it is clearly, we can see clearly from our diagram that we have a triangle like this. Let me put it there, and FR. This triangle is a right angle triangle. Somehow here we have a 90 degrees. Don't forget the concept of trigonometry. Whenever you have a right angle triangle, we can use a theorem of Pythagoras to determine FR, which is going to be our resultant electrostatic force in this case. Then we are going to say FR squared. This side we have F of A and B. This side we had F of B and C. Then we are going to say F, B and C, then you square F, A and B, then you square. We use the theorem of Pythagoras to calculate FR. Then you just substitute at this point. For BC, we got 280, don't forget to square, plus 4500, you square everything. Then this one is going to be your FR square. For us to find FR, not FR square, FR, we want FR. To remove these two, we must square everything. Square everything. Then our FR is going to be, let us use our calculator. We are going to get 5300. Then this is going to be our FR. Don't forget that a force, an electrostatic force, is a vector quantity. We have managed to get the magnitude. Now, how are we going to determine the direction? At this point, we can clearly see that the direction of this is going to be different. Somehow we have to determine the angle theta there, which is going to be our direction in this case. For us to get this value of theta, we already have f of AB and f of BC. It is clear that the trig ratio that we are going to use at this point is tan. You can use sine because you already have your hypotenuse, which is FR in this case. But it is much simpler to use what? To use tan. Let us consider tan instead of sine or cos. Then how? We are going to say, let me write it here. We are going to say tan of theta. Tan of theta. Then our opposite is going to be FAB. Opposite over adjacent. Then our opposite, the side that is opposite to theta, is FAB. FAB. Then our adjacent is going to be BC. At this point, you just need to substitute everything. Let us substitute our values. For f of AB, we got 4500. Let us divide this value by our f of BC, which is 2800. Tan. Then you are going to press shift on your calculator, then tan to solve for value of theta. Going to be 400 divided by 28. Then your final answer is going to be, if I'm not mistaken, 58.11 degrees, which is going to be our direction clockwise from our x values. Clockwise from x values. See, clockwise from x, let me just say x-axis. Then this is a two-dimensional problem of electrostatic using Coulomb's law. I hope you understood. Thank you. Voilà.